Okay, hey, train your plants every day. Jordan Scoville coming at you from the STEM lab here. Now, in my last video, I talked about making tools and stuff like that, and I kind of wanted to get into some of my quantum mathematics about it just because I'm all fucking batshit crazy about it. And, well, in a place, and especially with a lot of setups you can do, I know in some of my other videos I was talking about doing video systems, not only for tutorials on how things are done, whether they be just a general all over thermaling or general all over rock facing or what have you. They are very difficult to do. um, I do these videos in a certain way because it comes with the 15-minute standard. I have the luxury of going 15 minutes. It's actually, it's sometimes it's not so great to take an hour to describe what you want to do. People get offset and taking off what they want to do, and you got to get good with condensing and expanding the universes. You're taking thermaling and you're saying we're going to expand that into safety, we're going to expand that into managerial, we're going to expand that into quantum mechanics, and that's an infinite system when you really think about it. And the tutorial itself should take 5 seconds or 5 minutes anyways. But of course, just in the regular process of that, you have physics, you have thousands of different, you have slabs, you have burning down, laying down, standing up, treads, tread ends, specialty burns for high veneer products and high end. There's a different way. I mean, I when I burn ends and stuff like that, I always burn them like they're specialties. Um, but sometimes you can get away with not breaking edges, and breaking edges you have to do. It's a part of the process, and to really take the time to do those videos correctly, you have to manage that system correctly. And a lot of that turns into a lot of the quantum mechanics into a place. So when I'm really talking about this kind of thing, I could take my whole entire quantum physics thesis here and I could break down every one of my terms that I bring up into my conversation. Yeah, number one here, A equals force, A equals F equals ma, matters and acceleration, or matters at A mechanics, is equal to force 1 thermally. Business models. I mean, there's already a lot going on there mathematically, but it's made out to be the laws of motion, how you run a tread line, how you thermal. That's the abbreviated algebraic form that I kind of applied mathematically to this. Erodes conjectures, an abruptly long sequence of reciprocating terms. Thermaling and that process is basically the same thing in A mechanics as working a saw or working a tread line. It's just reciprocating in different forms that are abruptly and have constant differences between terms mathematically against the laws of motion. And we'll get into a lot more of this in a second here, but Fermat's last theorem is AX plus BX equals CX. It's not only the process, but the specific special relativity given this case. We're saying that you could break down the specific forces, you could break down the specific models. And Beal's conjecture is AX plus BY equals CZ, which is the model that not only can it diverge and have those same processes other places, but also when the stone changes size, when this bay system needs to set up differently, when you got to do 5 different patterns of thermaling on a stone or what have you. Ooh. Boy, good thing it's Saturday. Then you have the Yang-Mills mass gap, and being able to describe that conversation with a managerial conversation with just a regular grinder that's thermaling or treading, that's a mass gap. A lot of guys have a problem understanding that with motivation and dedication and just the way they work, and that can be a mass gap for them that they'll never be able to bridge or make the quantum leap to achieve. And this is just my version of it. I use the grind to help me do this. So if you got another one, hey, by all means. The P versus NP problem is organizing universal field theories. Now again, you could to teach a mathematician how to do thermaling, I'm going to start with the laws of motion. Look, there's a force and equal force here. I'm not going to get into thermodynamics and the little vapor explosion that happens inside the rocks and thermodynamics and everything like that causes that thing to shoot off of there. It's not just the pressure or the gases off the torch, it's actually a little explosion happening. I'm not going to get into laws of motion. I'm going to tell you this is law 1. You turn on the freaking torch and you go, because those are the universal field theories. Those are those terms at BY, AX, BY, to causally function, the C, causal, function, Z, mathematically, to apply what's going on here. I'm not going to teach you laws of motion. I'm not going to teach you thermodynamics. Of course, that stuff going on at the subatomic level here. But in terms of what we're doing in the BY universe, the third dimension or fourth dimension space-time variable here, that shit's not important to you. So that's why I could go mathematics. I could do one company, several companies, a landscaper's map, all in their kind of order out to understanding in group sets. You know, a lot of resumes, a lot of different skills happening in each resume, just like you add out to a resume. In any landscape, there's a bunch of different skills. They all apply to business, back to the universal field theory, but each one of those can expand individually to their own field theory of just one skill that somebody might make their own business back down to 0 and 1 and infinity and 2 and whatever. Then you get into Sun Tzu and Military Joint Chief of Staff dictionary of terms and quotes and quatrains and whatever you believe in, you know, whatever. Not for me to judge, I'm just saying. Brick and Dreyer's conjecture here, which is, you know, kind of looking at halfway through the middle and talking about, I think that's prime systems, if I'm not mistaken. Let me see just real quickly here. Let me take a look. Oh, no, that's applying that into an integer or a real number. You know, it says you can't, 25. Well, what the hell is 25? 25 is 1.5 inch, I think that's 1.5 inch pieces. I think it's 18 for 2 inch on a pallet. But you would never know that number, that integer, because it's real numbers. That's its form. Its globular state is a stone dock. That's why I apply it to a universal field theory, a McDonald's, a home life, and how you set that up. That's a real integer when you apply mathematically a mechanics. Ugh, you know, ugh is yes. Ugh is what? Ugh is yes. They're both. It's just the integer by the combination of letters and how we generally is important conversation here. How everybody agrees that this conversation lays out as an alphabet, how everything sounds, and we all understand that to be one correct answer. 1 is an integer, a real number. So x2 plus y2 equals z2. Basically, it's the lion's mentality. You know, I'm confident here. You're going to believe me. I'm going to walk you through it, even though x2 is nothing. It's a zero state. It doesn't mean anything. Yeah, Hodge's conjecture, which is, let me just take a peek real quick here, make sure I got it right. It's not Hodge's conjecture. It's the shape of complex objects. You know, when we're talking about the calculus that goes into it goes into real numbers and on papers and forms using general relativity, you could say, using that system and all the blank stuff that I don't see in dark matter, I could basically generally understand what the shape of their tread line looks like, but you got to know a lot to do that, and you're gonna have to know some of those other equations to go with this. So I'm just running through this real quick, and there's a million different ways you can do this, so don't get too locked in. Physics of common sense, Aristotle's physics. You know, I use this for Murphy's law. Not only if it can go wrong, it will go wrong, but Murphy can make new rules. You know, this has got a lot of Aristotle and physics in it. It's got everything it needs it to do. It's locked in. So it's inventions. It's, you know, well, it's not just inventions. It's a ball in water and a ball in oil. Without this, it's a ball in water. It's just going to fall too fast. There's going to be a lot of different velocities and accelerations. But even with this, there's the same. But this is in oil. It's more viscous. So there's a different viscosity to how that whole system works up when I'm rock facing and things like that. This changes that variable, but it's the same mathematics that go into it. It's just changing forms and what have you. Cryptology, code, and ciphering. For me, it's I do this again. The language barrier. I talk about the stone dock using psychology. It doesn't always need to be code programming or how you program a saw, or because sometimes those saws in the docks and McDonald's programming, it's the brain mechanics programming. It's psychology. There's a lot of A equals B substitution transposition codes. They can just that fast. Chemistry and physics, and it's all there. Mini a Bitcoin. Let's take this process to thermaling, and every one of its millions of different diversified system safety managerial, and just put it in 5 megabytes, 5-minute video. That can be an idea of a code programmer's mathematically, which is about taking 13 megabytes and condensing it down to 10 megabytes or 12 megabytes to win a prize. That's be a general. S.T.E.M method, which is psychology explaining this stuff. If you can do this stuff right, it's ethics, it's motivation, it's economics, that's the S.T.E.M method behind a lot of this. Scientific method, which is again basically coding. It's basically a mechanics. It's forming a hypothesis. Will it work out when I set up the bay like this before I go ahead and start moving it? Well, think about the sizes. I can't put a 12-footer there, but I can put a 3-foot pallet there or something like that. That's in a way a scientific method. Beyond that, how far are you taking it? That makes a difference that I need to specify here, and not only on paper but also in the place and in your head. Those would be your AX, BY, CZ spectrums, in space-time that you need to know. 4th and 5th dimensional calculations of general relativity. 4th dimensional space-time. Photonic science, things that don't matter but really matter. That stone you kick around on the ground, it's a radioactive power plant, waiting for you to tap in that energy by cleaning it, or waiting to go critical mass by stepping on it, tripping on it, spending a half an hour extra at the end of the day cleaning up when you didn't have to. Things that you don't think matter, that really do. Photons don't have matter. They don't weigh anything. That's in a massless photon in a massless box, and you write all this stuff down and you write all these rules down. Well, that doesn't apply to me. They matter. Hunter's prize, I like to say, catching the rabbit. This is again catching those. It's a coding game. It's about programming into a computer. Something, I forget what it is, but basically, can you trap that rabbit? Can you contain within the system with general relativity what you bring to the game, what generalizes this bay setup? That even though there's a million different things to do, can you lay all that out on a piece of paper? So even when I have a different order or cut, or the stone doesn't bring in 12 footers all the time in my bay setup, that then I recondition this in all the same spaces to now do browns and variegateds instead of just blues. 12s, 11, 10s, 9s, 8, 7, 6, 5, 4, 3s. Can you make that switch fast enough? That's what I look at, that Hunter's prize. His name was Hunter. It doesn't. I play general relativity. Matrixing. Matrixing goes again in a lot of this. Your base setups. It's your cell phone. When you look at that, that's a matrix setup. Not because all the complex mathematics. We're talking about quantum and general relativity here. But I have all my S.T.E.M problems set up on there on one matrix of it. I got my game set up over here. I don't have many games, I'm just saying. I got all those systems, and they all do different things. My mathematics one is algebra, trigonometry, physics, quantum, what have you. And that's a matrix, and they're all going to be different things, because even though they're the same thing, I understand the reality that some math equations really apply a specific function. Hydraulics, water conduction. I need a higher, tighter flow out the end of that nozzle, or I need to slow it down with what kind of pressures on the back end. Obviously common sense physics says get a bigger or smaller one, but when you really want to understand those models, you got to know the numbers, and it'll tell you exactly what number that is by measuring out the diameter of that inside valve and what have you. Diversified inconsistency. Do I really need to get into this? I talk about it all the time. They're time systems, they're measurement systems, that's weighing systems, how much something weighs and how much goes in, it's just a law of diminishing exchange, which has a lot to do with diversified inconsistency, triage, Murphy's law, flaw, semiotics, simultaneous relativity, general relativity, a whole bunch more. Catch you in the next one.